to Beyond the Basics, a reference guide for mathematics. This is episode 2. In episode 1, we created a table of contents in our notebooks, just like this. And now in episode 2, we are going to explore the number system. We are going to diagram the rational number system within the real number system. We're not going to be looking too much at the real number system, just kind of a glimpse, but we are going to dial in really close to the rational number system. And then we also define all of the different number categories and systems, and then we are going to do some practice identifying those different systems, so using our skills. Why do you need to know the different number categories? I mean, is it really useful in everyday life? No, probably not. But as I said before, this video is for preparing you to go to Algebra 1 and beyond. Math has kind of a different language of its own. And if you don't understand the words that are used in math, then it's kind of difficult to understand the math itself. So we're going to look at these terms and explore what they mean so that when you get into higher mathematics, that you have a better idea of what's being talked about when they talk about the real number system, imaginary numbers, rational numbers, integers, whole numbers. I don't really get into natural numbers because there's two different schools of thought on what a natural number is. Is it a whole number? Is it a counting number? I also like to put things in categories. When you can put something in a category in your mind, you understand more about different facts about it. You understand its capabilities and its limitations because it's in that category. Let me give you an example. You turn the TV on and there's a sports game on, probably hockey. And you look at the team and they have jerseys on. You're like, oh, I know that jersey. That team is from St. Louis. They're the Blues. They have this record. They have that record. They won the Stanley Cup in 2019. You know all sorts of facts about them just because they're in a category of the team of the St. Louis Blues. So categories allow you to know more information about something without actually exploring and researching that information because it's in that category. Same is true for these numbers. If I can say, oh, that number is an integer, I automatically know it doesn't have any fractional pieces. It's not between any numbers, it is on a number. Number systems. Now we're going to start with real numbers. Real numbers, and yes, there are imaginary numbers. If there's real numbers, there are non-real numbers. Real numbers are any number that can be plotted on a number line. Imaginary numbers cannot be plotted on a number line. Brief history of imaginary numbers. Imaginary numbers are, basically it's the square root of -1. So a square number, like 2 times 2 is 4. 4 is a square number. The square root of 4 is 2, okay? If I take the square root of -1, I would have to find a number times itself that would give me -1. And you can't do it because a negative times a negative is a positive. So there is no such number that is the square root of -1. Why do we even think about it then? And that's a good question. It actually is going to come into when you are studying quadratics in Algebra 1 and in Algebra 2, you look at complex number systems and the quadratic formula. Occasionally you will end up with one of your factors being an imaginary number, a complex number with a square root of -1 as a part of the answer. And so they use the number or the letter I as the designation for an imaginary number. We are not going into the imaginary numbers at all in this series, so that's just a basic glimpse. Real numbers are made up of two categories. You have the rational numbers and the irrational numbers. Rational numbers can be written as a fraction, irrational numbers can't. Then you have the integers. Integers are the ones that are exactly on the numbers. There is no in between, so they're all whole numbers. And then, of course, you have the whole numbers and the counting numbers. And those are the numbers that you've been working with since you started working with numbers. 0 and then all of the positive whole numbers. That's what they are. Now it's time for your notebook. So you're going to get your notebook out and your colored pencils and your gel pens or whatever color you decided. And whatever I write in my notebook, here's the finished product because I already videoed it, you write in your notebook. Do the colors have to match exactly? No. I like using rainbow colors just because it gives an order to stuff because Roy G. Biv, it has a beginning and a middle and an end, and that makes it easier to follow a pattern. In this case, you can choose any color that you want to represent what we've got here. We start out with the real numbers. So you notice I have a box around real numbers, a red box that goes several lines tall. I believe mine is 7 lines tall. Make it at least that. Probably one more would be better. The real numbers consist of the rational numbers and the irrational numbers. And notice I put the irrational numbers outside the box of the rational numbers. I've grouped the rational because that's where we're going to dial in our focus today. Irrational numbers are decimals that never end. You have decimals that can be written as fractions, such as like 1/3. It's a decimal that never ends because it's 0.3 repeating forever and all eternity. But repeating decimals can be written as fractions. Non-repeating, never-ending decimals can't. So, for instance, pi. Most people are familiar with pi. It's 3.14159265535. But it is a ratio of circumference to diameter, and there's no way to find the end of it. It will continue forever, and it does not repeat the same pattern over and over and over again. Then you see there the square root of 2. There's actually the square root of any non-square number. So like earlier I mentioned that 4 was a square number, and its square root is 2. Well, 2 is not a square number because there is no number times itself that's 2, because 1 times 1 is 1. So the square root of 2 is between 1 and 2, and there is a way of narrowing it down and figuring out what it is, but you always get closer and closer and closer, and you never actually get to it. The decimal goes on and on forever without any repeating pattern. Those are your irrational numbers. They can't be written in fractional form. You can estimate the fractions, so you might have heard of 22/7 representing pi. It can represent pi, but it's not pi itself. It's close enough for our measurement purposes, but it's not exact. Rational numbers, however, are any number that can be written as a fraction. So these numbers you see, 5.5 can be written as 5.5 or 11/2. All of those are numbers that are either have decimals that end, or like in 0.3 with the bar above it, that's a decimal that repeats. So repeating decimals and what are called terminating decimals can be written as fractions. Any one of those numbers that you see there could also be negative, because you can have negative fractions and negative decimals, but then you also have these numbers. -3, -2, -1, 0, 1, 2, 3, and you notice the ellipses go on and on in both directions because it goes to negative infinity and positive infinity. It goes in both directions. Those numbers are what we call the integers. And the integers have no fractional pieces. So you'll notice the fractions and the decimals are on the outside of that integer box. They are not included in the integers. The integers are those special rational numbers that don't have fractions. Within the integers, you have the whole numbers, which basically excludes all of the negative numbers. And then within the whole numbers, you have the counting numbers, which basically excludes 0. Each one of these categories has a characteristic about it that tells you more about the numbers. Counting numbers, those are the numbers you've been using since you learned to count. Whole numbers is the understanding of a 0, and then you have a 1, and then you have a 2. Those are your whole numbers. Integers then include the opposites of the positives. So you have the negatives. Although negatives technically are whole numbers because they don't have fractions, they're not in the whole number category because they're negative, and whole numbers are positive. Your rational numbers include all of those integers because integers can be written as fractions by simply putting them over 1. So -2 over 1 is a fraction. 3 over 1 is a fraction. So they can all be written as a fraction. That's why they're all in that orange rational number box. But the irrational numbers are excluded from that box because you can't write them as fractions. So they can be plotted on a number line, but they can't be written as a fraction. That's the basis of the real number system and the rational numbers. Now we're going to define each one of these categories a little bit closer. So here you see the real number definition, and I apologize, I do make it neater later on, but this first photo, it's a little bit scruffy looking. So you have real numbers are numbers that can be plotted on a number line, like this. This is a simple number line. 0 is the center of every number line. Here's pi. Pi is 3.14, so it's a little bit bigger than 3. The square root of 2 is 1.414, and it goes on forever. So it's about, in this location, just less than 1.5. Those can be plotted on the number line. So can any of the other numbers, any of the other fractions, any of the whole numbers, any of the counting numbers. You can actually see them on the number line. So they are all real numbers. And then you have your rational numbers, numbers that can be written in fraction form. So like half is in a fraction form. 1 3/4 is a mixed form of a whole number and a fraction, but it can also be written as a fraction because it's 7/4. Or you have like whole number 2 can be 2/1, or the negative, the integer, -3 could be written as 3/1, or in this case, 6/2, -6/2. And I have a reason for doing that, and you'll see why later in the video. Integers are whole numbers and their opposites, and 0, because 0 technically has no opposite. So 2, the opposite of 2 is -2, and the opposite of -2 is +2. And as I said earlier, 0 has no opposite, but it is one of the integers. It is not positive, nor is it negative. Whole numbers are numbers without fractions or decimal amounts, and since integers include the whole numbers, then integers also don't have fractions or decimal amounts, such as 3 or 3.0 is a whole number because the fractional amount is 0, but 3 3/4 is not a whole number. And then you have your counting numbers, the numbers that are used to count. Now let's practice. Why do we need to practice these skills? Practice is probably more important than writing the notes. And writing the notes is extremely important. So writing the notes is like way up here. Practice is just above that. Because if you're going to learn something, you have to make it make sense in your own mind. And the best way to do that is for you to try it on your own and make it your own process. You might think the way I do. You may not think the way I do. But you will figure that out as you practice it. And the more you practice it, the more connections you're going to make in your mind, the more neural pathways you're going to make, the easier it will be to remember. By practicing it over and over again, you create your own understanding, which is far better than trying to use somebody else's understanding that doesn't make sense to you. Use your own understanding and it makes sense to you. When you do these problems, you're going to write the answer of what categories number is in, and I'll give you an example. You're going to write the categories and then you're going to write out your reasoning. Writing it all out helps your mind make sense of it and remember it's so much better than just putting the answers. This is where the teacher always says to show your work. It's so that your mind can start to make sense of the topic that we're studying. We're going to use number 1 as an example. Number 1 was the number 2. So 2, we're going to see what categories it's a part of. So we ask ourselves some questions. Is it real? Can I plot 2 on a number line? Yes, it is real because 2 can be plotted on a number line. I asked myself, can it be written as a fraction? If it can, then it's rational. And 2 can be written as a fraction. On your answer, you would write real. It can be plotted on a number line. Rational, it can be written as a fraction of 2/1. Is it an integer? You have to ask yourself, does it have any fractional pieces? It is an integer because it has no fractional pieces. Is it a whole number? It is a whole number because it is positive. Is it a counting number? Yes, because it is greater than 0, because all counting numbers are greater than 0. So that's what your answers are going to look like. The number 2, it's real, it's rational, it's an integer, it's a whole number, it's a counting number, and each one of the explanations written with it. If you choose to skip any part of that, then you're not going to have as good a memory of this when it comes to using it later on. So you're going to practice. I'm going to have you pause the video until you're finished working on all the problems, then come back to check your work. So number 2 was 3/4. Ask yourself this question. Is it real? Can it be plotted on a number line? Yes, it can. So you should have real number. It can be plotted on a number line for 3/4. The next question was, is it rational? Can it be written as a fraction? Well, that's obvious. It is a fraction. So yes, it's rational. It can be written in fraction form or it can be written as a fraction. Is it an integer? Is it an whole number or is it between whole numbers? If it is between whole numbers, it is not an integer because integer is only those whole numbers and their opposites. This one is not an integer because it's between 0 and 1. If it's not an integer, it's not a whole number or a counting number either. Hope you did well on that one. If not, it's okay to go back and correct. Like, if you put that it was an integer, just erase it's not an integer, or out to the side write no because it's a fraction, and correct that in your mind. Making those mistakes are not bad at all. Correcting them is crucial. -12. Ask yourself the same questions. Is it real? Yes, it is. It can be plotted on a number line. Is it rational? Yes, it is. It can be written as a fraction. Is it an integer? Is this one an integer? Or does it fall between integers? This one is an integer because -12 has no fractional pieces. Is it a whole number? This one gets confusing for some people because it doesn't have any fractions. Does that put it in the whole number category? If you remember back to when we were defining it, your whole number category is defined as all positive numbers. Is -12 positive? No, even though it doesn't have any fractional pieces. And if it's not a whole number, it's not a counting number either. 1,234. Is it real? Yeah, it can be plotted on a number line. Be a rather large number line. Is it rational? Yeah, it can be written as fraction of 1,234 over 1. Is it an integer? Does it have any fractional pieces? No, it doesn't, so it is an integer. It is not between numbers on the number line. Is it a whole number? So remember, the difference between an integer and a whole number is basically, is it positive? It is. Is it a counting number? Yes, it is, because it is greater than 0. So that one, again, is all 5 categories. 1.45. Is it real? Can I plot that on a number line? Yep, it would be between 1 and 2, just slightly less than 1.5. Is it rational? Could I write it as a fraction? Yes, I can, because I could write it as 1 and 45 over 100, or I could write it as 145 over 100. Is it an integer? Does it hit the whole numbers on the number line, or does it fall in between them? And it's not an integer because it's between 1 and 2. And if it's not an integer, it's not a whole number or a counting number. This one is only in 2 categories. 7 and 5/6. Is it real? Can I plot it on a number line? Yes, I can. It'd be between 7 and 8. Is it rational? Yeah, it's almost in fractional form. It's in a mixed number form. Is it an integer, or is it in between integers? This one's between 7 and 8, so it's not an integer. And as before, if it's not an integer, it's not a whole number or a counting number either. -1.125. Is it real? Can I plot that on a number line? Yes, I can. Is it a fraction, or is it rational? Can I write it as a fraction? Yeah, that's actually -1 and 1/8. Is it an integer? This one's between -1 and -2, so it is not an integer. And as I said before, it's not a whole number or a counting number either. This is the last one, the weird one that I warned you about earlier, except earlier it was a -6 over 2. Is it real? Can I plot that on a number line? Sure, I can plot that on a number line. Is it rational? Can it be written in fractional form? Yeah, it's already in fractional form. This is the tricky one. Is it an integer? Looks like a fraction, so wouldn't that be between the numbers on the number line? Let's try simplifying it. 6/2 is like 6 divided by 2, which is 3. And 3 is an integer, which means if I plotted 6/2 on the number line, it would be plotted on 3. It is not between the integers, it is on an integer, so it is an integer. Is it a whole number? Is 3 a whole number? Yeah. So 6/2 is just another form of the number 3. It has no fractional pieces, and it's positive, so it's a whole number. Is it a counting number? 3 is a counting number. So 6/2 is another way of representing 3, so it is also a counting number. Keep practicing. If you're in the classroom, then you're going to be doing some practice on a piece of paper with several problems to practice. If you're on your own at home, or if you are a parent or a teacher, then I recommend that you practice identifying these numbers, probably at least 15 numbers today. Again, writing out the category and the explanation on all 15. And then you continue doing 15 more over the next few days, like 5 tomorrow, 5 the next day, 5 the next day, because when you have to recall a memory over and over again, it makes that memory much easier to remember later on. And then revisit this over and over to create a more permanent memory. Hope you enjoyed our video today. The next video will be on, oh yes, fractions and decimals and their connection. Thanks for watching Beyond the Basics, Episode 2.